Let's take a look at two problems, one involving the connection between alpha and our confidence level, and one involving type 1 and type 2 errors. So we've got this question here. We have conducted a one-sided hypothesis test with the significance level of 1%, and as decimal, that's 0.01. We'd like to also construct a confidence interval with an equivalent level so we can compare our results. What should the confidence level of this interval be? Okay, so a picture goes a long ways for this one. I'm going to draw a normal curve. And when you're drawing this curve, when you're making an interval, it's got that plus or minus. So your confidence level C lives in the center. C for center is a good way to remember that. Now, our alpha level is going to either be the size of one tail or the combined size of both tails. And we'll see what the case is here. It says we did a one-sided test. Okay, so that tells me left or right, it doesn't matter too much. We'll do right. They used an alpha level of 1% for this tail. Now, that means the unshaded end tail on this opposite side is also 1%. And that leaves me with a confidence level of 98%. So if you have an alpha level of 1% and it's a one-tailed test, this is going to give you a confidence level of 98%. Now, just to have it for comparison, here's my normal curve, alpha of 1%. Suppose this was two-tailed. And I want that confidence level C. C still lives in the center. If it's two-tailed, that tells me that both of these tails are shaded in, and they have a combined area of 1%. Not 1% each, 1% in total. So when I'm looking at the two-tailed test, it would actually be 0.5% in each if you wanted to split that up. So that's the big difference between one-tailed and two-tailed. One tail is giving you the size of one of the tails, and two-tail is giving you the size of both of the tails together, not individually. If I have 1% so far, that leaves me with 99% in the center. So depending on if I'm doing a one-tailed or two-tailed test, an alpha of 1% is linked with either 98% or 99%. In this case, one tail, 98% is down here. That's looking pretty good with that green check mark. That's how I do that connection between alpha and C. And confidence intervals and hypothesis tests really are related concepts. So a question might be, okay, why don't I just be like 99.999% confident all the time? And if you did that, these tails would get so tiny that you would never reject that null hypothesis. It would be almost impossible to have evidence of something. So there's this balancing act. I'm trying to avoid error. And there are two types of errors that can happen, type 1 error and type 2 error. Let's look at those for this next problem. The food safety inspector is called upon to investigate a restaurant with a few customer reports of poor sanitation practices. The food safety inspector uses a hypothesis testing framework to evaluate whether regulations are not being met. If he decides the restaurant is in gross violation, its license to serve food will be revoked. Part A says write the hypotheses in words. Okay. Null hypothesis, alternative hypothesis. Null. Null with that 0 there means no change, and it'd be the status quo. So it's what you would hope for sort of the base standard. If you have these things flipped, Not the end of the world, because we'll see how that would change in later parts. As long as you're consistent, it's not that big of a deal. But I think it's assumed that when we go into a restaurant, that the null hypothesis is that there is no food safety violation. In the alternative hypothesis, there would need to be evidence for me to say that it is unsafe. So that's how the inspection process works. It assumes that things are okay unless they find something, and then they revoke the license. So status quo, no safety violation. Alternative, a safety violation. There are other ways to phrase this. You might phrase it differently, and that's okay. A type 1 error. In a type 1 error, the first thing is true. So there is no actual safety violation. The error part is going to be a but to this. So there's going to be a but something else, and it's going to be the opposite. So there is no safety violation, but they get written up. So they're not doing anything wrong, but they're going to get their license revoked. So all of the errors are going to have two pieces: the reality of the situation and what the test says. And in an error, those are different things. You would hope that if there's no safety violation, it's an and they do not get written up, that they match up. The error is when they don't match. Type 2. The second thing is true. So the second thing being true here would mean there is a safety violation. So maybe there's some food handling thing that they shouldn't be doing. But, and now here's the disconnect. So in actuality, it's not safe, but they don't get written up. So in that situation, they're not getting written up. They're saying there's no safety violation, but they really should have said that there was a safety violation. So you could say that they incorrectly failed to reject the null hypothesis. In this first one, they said there was a safety violation when there wasn't. So another way to say a type 1 error is they incorrectly rejected the null hypothesis. Neither of these things are good, and I think point of view matters a lot. Which error is more problematic for the restaurant? Well, I think the restaurant would be concerned about their license getting revoked when there's nothing wrong with their food. So a type 1 error would be a big concern to the restaurant owner. If I was a diner, I would be more concerned about a type 2 error, that there's actually something wrong going on and I'm eating food that's not safe for me to eat. As a diner, would you prefer the food safety inspector requires strong evidence or very strong evidence of health concerns before revoking a restaurant's license? Ooh, super complicated. I look forward to seeing some of your answers for that particular question. You might be of the opinion that you want to make sure there's a lot of evidence because you're afraid of them losing their jobs. That's a great reason. You might say, I just want to have some evidence and I want you to err on the side of closing things so people don't get sick. I think either of those answers, very different answers, are valid. Ultimately, this last question here is really one of your opinion. But the idea of there being a perfect situation is not always possible in statistic. Error is unavoidable. And the best thing that we can do is weigh and understand what these things represent. So I hope that helps there a little bit on this lesson involving type 1 and type 2 errors. and the connection between alpha and our confidence level C.